40 starships have initiated the firing of nuclear missiles aimed at the poles of Mars, marking the commencement of a grand display. A united nation is fervently pursuing a shared objective, transforming a barren rock into a lush garden. The missiles detonate in succession high above the Martian surface, birthing to radiant suns in the skies over the North and South Poles. Thus begins the process of terraforming Mars, where the frigid, radioactive, and desolate desert landscape is undergoing a rejuvenation into its verdant past. Temperatures are climbing, ice is melting, and the atmosphere is thickening, initiating a chain reaction of greenhouse effects. Mars is undergoing a revitalization. What flora and fauna will thrive on this planet? When will humans assume control and launch extensive terraforming endeavors, such as establishing a magnetosphere, infusing oxygen, and seeding the planet? Or will the passage of time witness newer generations acclimatizing to subterranean life in dome settlements, losing touch with Earth, and lacking the drive to continue the multi-generational terraforming endeavor as the two suns gleam brightly above the poles? Phase 1 of Mars terraforming unfolds with the extraction of CO2 ice. Mars' chilling conditions result from its scant atmosphere, merely 1% of Earth's, insufficient to retain solar heat. Any surface water swiftly freezes or evaporates due to the low pressure, which also depletes oxygen from human blood, causing circulatory failure within a minute, necessitating pressurized suits for survival. The dual nuclear suns commence the thawing of ice caps, releasing CO2 and water as gases into the air, thickening the atmosphere. The planet's temperature ascends, transitioning from an average of -60 degrees Celsius (-76 degrees Fahrenheit) to -40 degrees Celsius. Terraforming initially manifests in the warmest equatorial regions, deep craters, and valleys, where liquid water emerges sporadically. As the surface warms and more CO2 and water vaporize, the atmosphere densifies, trapping heat and accelerating the terraforming process. The runaway greenhouse effect takes hold as Mars, akin to an advanced AI, self-programs for further enhancement. With temperatures nearing 0 degrees Celsius, 32 degrees Fahrenheit in more regions, subterranean ice melts, water surfaces, and ancient riverbeds witness a resurgence. Evaporating water vapor leads to cloud formation, initially yielding snow and hail, eventually transitioning to rain, initiating the water cycle. The crimson dust veil on Mars gradually dissipates as rivers meander, albeit sluggishly due to lower gravity, inundating most of the planet with water, recreating primordial oceans. While 87% of Mars' ancient oceans had dissipated into space, the remaining stores in polar ice caps are replenishing, envisioning a future Mars adorned with an ocean over a mile deep, covering over 20% of the planet as the atmosphere thickens, shielding against radiation. Mars' sky adopts a light blue hue. Water infiltrates subterranean crevices, potentially reviving dormant Martian bacteria, which, aided by growing water pools, a denser atmosphere, and sunlight, proliferate on the surface. These resilient bacteria, capable of enduring harsh conditions, may originate from Earth if no indigenous strains survive. Bioengineered bacteria, tailored for Mars' environment, are introduced to catalyze soil formation, paving the way for more intricate life forms. Algae, grasses, and moss mark the initial botanical inhabitants, signifying Mars' partial terraformation, where oxygen masks remain essential, albeit unnecessary in lower southern plains regions. Advancements in genetic engineering and cancer eradication on Earth empower astronauts to dwell on Mars' surface without radiation concerns. Strategic redirection of asteroids and comets targets Martian deserts to supplement the thin atmosphere with additional materials, augmenting ice and nitrogen content. Fusion reactors, interlacing Mars with superconducting cables, herald a new era, revitalizing the planet's magnetic field through the Solenoid Loop project. This engineered shield fortifies Mars against solar and cosmic radiation, nurturing an environment conducive to complex life forms' evolution.